Hello. Today we are going to solve October-November 2018 2-1 paper. It's Physics 5054 course. Today in this video we will be solving only its section A. So let's start. On your screen you can see question number 1. A girl of mass 35 kg on a bicycle accelerates from the rest and travels down a slope in a straight line. The girl does not use the pedals. Figure 1.1 shows that the gradient of the slope is constant. Calculate the resultant force on the girl when she is accelerating at 2.6 meter per second square. You see, the mass of the girl is given 35 kg. The acceleration of the girl is given 2.6 meter per second square. So very easily, by using the Newton's second law of motion, whose equation is F is equals to ma, we can calculate the resultant force. The formula for the resultant force is F equals to ma. The mass is given, the acceleration is given. Please look at this calculation. On your screen, you can see question number 1A part. F is equals to ma. 35 multiplied 2.6. The mass is 35 kg. The acceleration is 2.6 meter per second square. And the answer will be 91 Newton. It's a 2-mark numerical. It's easy. I hope you have understood. Okay, let's move to the B part. In the B part, he says, let's increase the size. Yeah. At first, her acceleration is constant. At time t1, her acceleration starts to decrease gradually until she is traveling at a constant speed in a straight line. On figure 1.2, sketch a speed time graph for the girl from when she starts moving until she is traveling at a constant speed. Okay, so it's a two marks question, and we have to draw on the given graph. So on the y-axis of figure 1.2, you see speed is represented, and on the x-axis time is represented. And in the given information, he has told us till t1 he has moved with the constant acceleration. So what I will do, I will draw an inclined line with a positive slope, and when that line, I will draw a line here. I will draw a line here like this, a straight line. It shows a constant acceleration. The gradient of the speed time graph is equals to the acceleration. If the acceleration is constant, I will draw a straight inclined line whose slope do not change. Then after, when you have touched this dotted line, then I will draw a decreasing curve, and I will decrease it until it becomes horizontal. I have drawn this on a paper. Let me show you. Question number 1B part is first section. On the graph, on the diagram, you can see till t1, I have drawn a straight inclined line with the positive slope, which means on the speed time, this means a constant acceleration. Then I have drawn a decreasing curve, which means the value of the acceleration is gradually decreasing. Then I have drawn a horizontal line, which means that the body is moving now with a constant speed. The acceleration has become 0. So it's a 2-mark question. I hope you have understood it. Next, the second part of the B is state how the distance traveled is found from a speed time graph. It's a 1-mark question. You see, whenever you have a speed time graph and you want to calculate that how much distance is traveled by the body, you will calculate how much is the area under the speed time graph. the area under the speed time graph is equals to the distance traveled by the body. Let me show you the answer which I have written. Area under speed time graph is equal to distance traveled by body. So it's a 1 mark question. So I hope you have understood it. Now let's move to the next question. Here on your screen, we have question number 2. A small crack appears in an oil tank and a stream of oil is pushed out through the crack. The oil hits the floor at P, where a puddle of oil starts to form. So what is happening here? You see in this figure 2.1, we have a tank. This is the top of the tank which is open. This tank is full of oil, and here we have a crack. And from this crack, the oil is streaming out. And this oil is coming out and it is touching the ground at point P. Okay, so this is the situation of the question, the story in the question. Now the question, the gravitational field strength G is equals to 10 newtons per kg. Question number 2, part A. The density of the oil is 490 kg per meter cube and the crack is 3.3 meter below the surface of the oil. Calculate the pressure due to the oil at the level of the crack. You know, oil is liquid. If you want to find out the pressure of a liquid, the formula is pressure equals to rho GH, where rho is the density of the liquid, G is the gravitational field strength, and H is the depth of the liquid above that point. So you see, if I want to calculate what is the pressure of the oil at this crack, I should know the density of the oil, and I should know the gravitational field strength, and I should know the depth of the liquid above this point, which is 3.3 meter here. So I will apply the formula and it will be very easily, I will be able to calculate it. Okay, on your screen, you can see question number 2, part A, part first. The pressure is equals to, let me increase the size, we can increase the size. Yeah. The pressure is equals to rho GH equals to, the density is 940, the G value is 10, and the H value is 3.3. Multiply them, you get the answer 3.1 expo 4 Pascal. It's a 2 mark numerical. I hope you have understood it. It's very easy. Okay, so move to the next part. Question number A, part second. Explain why the atmospheric pressure does not affect the rate at which the oil is pushed out through the crack. See this opening at the top of the tank? The atmosphere pressure is acting on the top of the tank on the oil from this top. The atmosphere pressure is also acting here on the crack. So the oil here and the oil coming out here, they both are experiencing the same atmospheric pressure. So that's why the effect of the atmospheric pressure is not considered here, because it is acting on both the sides. So you do not need to consider the atmospheric pressure. It do not have any effect on it. I have written this answer. Atmospheric pressure is acting on top surface of oil tank, and also it is acting on side crack. So atmospheric effect is not considered here. So it's a 1 mark question. I hope you have understood it. The B part of question number 2 is, as time passes, the point where the oil hits the floor moves away from P and towards the tank. Explain why this happened. It's a 2 mark question. Look, what is he saying? As the oil is coming out, this depth of the oil above this crack will start decreasing. So this H value, which we use to calculate the pressure of the oil here at the crack, that H value will decrease. Once that H value will decrease, the pressure of the oil in the crack will also decrease. When the pressure of the oil will decrease, instead of hitting the ground at point P, this jet will start moving. It will hit the ground a point closer to the tank. It might be hitting here, then here, then here, then here, and eventually it will touch this point. So the reason why it is moving, the jet is landing nearer and nearer and nearer to the tank. The reason is that the pressure of the oil at the crack is decreasing. And why that pressure is decreasing? Because the depth of the oil above the crack is gradually decreasing as the oil is leaking. I have written this answer also. As oil leaks, the depth of the oil above the crack decreases. So the pressure with which the oil is gushing out decreases gradually. It's a 2-mark question. I hope I have made my point clear. Okay, let's move to the next question. Question number 3. On your screen, we have question number 3. A student uses the apparatus shown in figure 3.1 to obtain the extension load graph of a spring. So you can see on the figure which is given to you, we have a stand, and with that stand, a spring is hung, and with the spring, we are hanging different loads. And we will note what is the length of the spring. And we will note what is by knowing the length, we can calculate what is the extension. The weight of the loads are known. The student suspends loads of increasing size from spring and determines the different extensions produced. Figure 3.2 is the graph the student obtained. So you see on your screen, we have extension and load graph. On the x-axis, load in newtons is represented, and on the y-axis, extension is represented. So it's extension load graph. And he has shown the graph till 7 Newton load. At 7 Newton, the extension is little less than 2. I think it is 18 centimeter. The spring reaches its limit of proportionality when the load is 7 Newton. On figure 3.2, sketch the shape of the graph for the load greater than 7.0 Newton. So you see, at 7 Newton, the spring has reached its limit of proportionality. So till this 7 Newton, the graph is a straight line, which shows that the extension and the load is directly proportional to each other. But after this point, on the extension load graph, the limit of proportionality has crossed. So if I will draw graph, extension load graph beyond 7 Newton, that graph should be a curve, an increasing curve bending upward. So let me show, it's a 1-number question. I have drawn this graph. So on your screen, you can see till 7 Newton, the graph is a straight line. And after the 7 Newton, when I draw the graph, I have drawn an increasing curve which is bending upward. So that shows that after the extension, the graph becomes a curve, and which shows the limit of proportionality has been crossed. And I have done not that much bending, but you should do a little larger bending. Okay. So it was 1-mark question. You have to plot on the graph. The B part is all the loads are removed from the spring. A block of wood is suspended from the end of the spring. The length of the spring increases from 4.9 centimeter to 13.4 centimeter. Determine the weight of the wooden block. So what we will do, first of all, the length of the spring, the original length of the spring is 4.9 centimeter. And when I hung the wooden block, its length became 13.4 centimeter. So first of all, I need to find out how much is the extension produced by this wooden block. So extension is equals to L minus L naught. L is 13.4 minus L naught is 4.9. So I will came to know the extension, which will be 8 point. I think I have drawn this. So when I will do extension equals to L2 minus L1, that will be 13.4 minus 4.9, and the extension will be 8.5 centimeter. Then using the figure 3.2, where you have drawn that graph, go to the load 8.5, and from 8.5 load, go to your extension load graph and read what is the corresponding value of the, sorry, I made a mistake. I said 8.5 new load. No. From your graph, extension load graph, look for 8.5 centimeter extension. And from the 8.5 centimeter extension, come to the graph. From 8.5 centimeter extension, come to the graph, and under that point, when that line touches the extension load graph, check what is the corresponding value of the load. And when you will do that, you will see the value is approximately 3.1 Newton. Let me show you how you will do this. You see, suppose, let me increase its size so you can clearly understand. So this is that graph. So the extension is 8.5. So 8.5 extension is here somewhere. So from here, go to the extension load graph, suppose here. And from here, go down and check what is the value of the load. Okay. So this is how you will be able to, because the extension is given 8.5 centimeter. By using the figure, I will be able to tell what is the load of that wood. Okay, so I hope I have made my point clear. It's a 2-mark question. Okay, so let's move to the C part. The student takes a second spring that is identical to the one in the figure 3.1 and hangs it next to the first spring. Figure 3.3 shows a light rod passing through the rings at the lower ends of the springs. The student repeats the experiment and gradually increase the load to 9 Newton. State and explain whether the limit of proportionality is reached. It's a 2-mark question. Look at this figure carefully. In the first figure, there was only one spring, and the loads were hung with it. But now he's using 2 springs. He's using them parallel to each other, and the load is hung with them. So the load, for example, now you hung a 9 Newton load with these 2 springs. The 9 Newton load will be distributed uniformly on each spring. So each individual spring will be not experiencing 9 Newton load. Each spring will be only experiencing 4.5 Newton load. So the load is equally distributed on both the springs. So the one spring will be experiencing only 4.5 Newton. The limit of proportionality for the spring is crossed when the load is beyond 7 Newton. So 4.5 Newton. So the limit of proportionality will be not crossed. I have written this answer also. Let me show you the C part. Yeah, this is on your screen. Because two springs are parallel to each other, load is equally distributed. 9 Newton load hung, but each spring experienced only 4.5 Newton load. So limit of proportionality, that is 7 Newton, is not crossed. It's a 2 marks question. I hope that you have understood it. Okay, let's move to question number 4. Question number 4 is on your screen. It says a rock from, let me increase the size. Okay, a rock from space is traveling at high speed towards the Earth. Complete the equation for the kinetic energy of an object traveling with the speed v and state what any other terms in the equation represents. The kinetic energy is equals to 1 by 2 mv square, or we call it half mv square. Here, m stands for the mass of the rock in kg, and the v stands for the speed of the rock in meter per second. This was a 1 mark part. Only you have to give the equation and you have to describe what the alphabets they represent. Okay, let's move to the next question. B part of the question number 4. The mass of the rock is 0.60 kg. When it hits the earth, its average temperature increases by 25 degrees centigrade. The specific heat capacity of the rock is 560 joules per kg per degree centigrade. Calculate the increase in the internal energy of the rock. You know, the energy or heat is equals to mc delta theta, where m is the mass, c is the specific heat capacity of the rock, and delta theta is the change in the temperature. So we can calculate the increase in the internal energy. I have done this calculation. Let me show you. So on your screen, you can see question number 4b, first part. Energy is equals to mc delta theta. M is 0.60 kg, C value is 560, and the change in the temperature is 25. You multiply them, you get 8400 joules. It's a 2 mark MCQ. I hope you have understood it. Okay, let's move to the next part. In the next part, he says use the answer from the B's first part to determine the minimum possible speed of the rock when it hits the earth. Suppose this energy is due to the kinetic energy of the rock. So the kinetic energy will be equals to the energy which you just calculated in the first part of the B. So make the kinetic energy equals to 8400 joules. Write the formula of the kinetic energy, 1 by 2 mv square. We know the mass of the rock. Put that value and find the value of the velocity or speed. I have done this. I have done this on a paper. Let me show you that. Okay. So on your screen, see kinetic energy is equals to 8400 joules, and 1 by 2 mv square is equal to 84. Put the value of m, v square is equals to 28,000. Take the under root on both the sides. So v will be equal to 167.3. So velocity is 167 meter per second square. So this was a numerical. I hope you have understood it. It's a 2 marks. It was a 2 mark numerical. Okay, question number 3. B's third part is on your screen. Let me excuse me for a minute. I have to let me excuse me for a minute. Okay. I'm back. Sorry for the inconvenience. Actually, the television shut down, the screen. Okay, so third part. Suggest one reason why the speed determined in the B second part is less than the actual speed of the rock when it hits the earth. You know, when the rock will hit the earth, it will not just raise the temperature. The energy which we just calculated in the first part was the energy to raise the temperature of that rock for 25 degrees centigrade. Uh, when a rock hits the ground, the temperature, not just the temperature of the rock increases, the rock also make a dent on the ground. It makes a depression on the ground. The rock, when it hits the ground, it also produces sound. The rock may shatter when it hits the ground. So all these things also need energy. So it means that the rock would have been moving at a higher kinetic energy, because that kinetic energy provided not just for it will not provide just the energy for the rise in temperature. It will also provide the energy for the dent in the earth. It will also provide the energy to produce the sound on collision. It will also provide the energy to shatter the rock. So the kinetic energy of the rock should be more than we just assumed in the second part. It means that the speed of the rock is much higher than we just calculated. I have written this answer also. Let us read that answer. Colliding rock has not only raised the temperature of rock, it would have created a depression on earth. It would have produced sound on collision. So that's why we believe that the speed of the rock is more than 167 meter per second. It's kinetic energy more than we just considered. So everyone, that was question number 4. I hope I have made my points clear to you. Okay, so we are moving to next question. Question number 5. A nurse uses a mercury in glass clinical thermometer to measure the temperature of a patient. Figure 5.1 shows the structure of a clinical thermometer. The clinical thermometer has a small range and a high sensitivity. State what is meant by range and what is meant by sensitivity. So here we have to define what is the range. So on your screen, I hope you are able to see. Okay, on your screen, you are able to see. I've written here the definition of range. The range of a thermometer is the difference between the maximum and minimum temperatures that the thermometer can read. This is the definition of the range. And the definition of the sensitivity is the sensitivity of a thermometer is defined as the increase in the length of the mercury column per unit increase in temperature. These are very famous definitions. So always remember them. Okay, let's move to the next part. The first part was of 2 marks. Each definition is of 1 mark. Okay, so question number A, its second part is state and explain one feature of this clinical thermometer that produces a high sensitivity. To produce a high sensitivity in any thermometer, the bulb of the thermometer should be of large size and it should be filled with large amount of mercury, because when it is filled with large amount of mercury, the larger the original amount of the mercury, the larger will be the volume expansion on the rise of temperature, and there will be a larger change in the length of the mercury column. So the thermometer will become more sensitive. Another way of making a thermometer more sensitive is to use a liquid, instead of mercury, use another liquid whose expansion is more as compared to mercury. So the same temperature will produce a larger expansion in that liquid, and the liquid will move a longer distance for the same rise of temperature. So it will make it more sensitive. So let me read my answer. I have also tried to write its answer. So you on screen, you can see question number A, second part. It has a larger bulb which contains larger amount of mercury. So there will be larger change in mercury volume when temperature rises. So there will be a larger movement in the length of the mercury column also. I hope you have understood it. Okay, so question number 5B part. State the purpose of the constriction in the clinical thermometer. You see this thing, this bend in the bore, this is called constriction. And the purpose of this constriction, it is once the mercury has moved onto the right side of the constriction, it do not let the mercury go back. So the reading on the thermometer is maintained for a longer time, and the doctor or the nurse or whoever is checking the temperature has ample time to read that measurement or to note that temperature. I have written this answer, that what is the function of the constriction. It prevents the mercury from running back into the bulb. Reading is maintained for longer time on thermometer. That was the B part. Question number 5, C part, is on your screen. Explain in the terms of mercury molecules how an increase in temperature produces an increased reading on the thermometer. You see, when the temperature rises, the molecules of mercury, they start vibrating vigorously, and their amplitude of their vibration increases. So the molecules move away from each other. So the mercury expands. And when the mercury is in the bulb of the thermometer and the mercury starts expanding, so there is no other way for the expanded mercury to go, but only the bore of the thermometer. So as the temperature rises, the mercury expands, and the length of the mercury in the capillary of the thermometer becomes larger and larger. It's a 3-mark question. I have written its answer also. Let me read that answer for you. So the question number 5C part is on your screen. When temperature rises, molecules of mercury starts vibrating vigorously. The amplitude of their vibration increases. Distance between molecules increases. Mercury expands and it starts rising in the capillary of thermometer. It's a 3-mark question. I hope you have understood the concept. Okay, now we are moving to the next question, which is question number 6. Figure 6.1 is the view from above of a stationary magnet and a small compass on a laboratory bench. Okay, so this is a bar magnet and this is a magnetic compass. State the material from which the compass needle is made. This compass needle is a permanent magnet. So it's normally made of steel, because steel is the material which is used to make the permanent magnet. So it's a 1-mark question. The answer is steel. You only have to state the name of the material. B part is describe how the small compass is used to plot a magnetic field lines in the region surrounding the magnet. You see, the method is very simple. You put the bar magnet on a paper and you mark its outer boundary. You take a magnetic compass and you put the magnetic compass near this north pole. Wherever the arrow of the magnetic compass points, you put a dot on the paper where the arrow of the magnetic compass is pointing. Then you lift the magnetic compass and you put the magnetic compass beyond that dot in such a way that the back of the arrow of the magnetic compass is touching the dot which you have just plotted. And then again you put a dot where the arrow of the magnetic compass is pointing. You keep on doing this process again and again until you have reached the South Pole. Then you join all those dots which you have just plotted with a curve or with a line. This is a magnetic field line which you have just drawn. And then you can start doing it again from a different spot near the North Pole. I have written this answer also. Let me read that answer to you. So it becomes more, it's a very, very famous question. This question comes in theory paper, paper 2. This question or this particular question also comes in the ATP paper. Let us read the answer. Place the bar magnet in the middle of the paper. Trace the outline of the magnet. Place the compass at one pole of the magnet and make a dot next to it showing the direction of the compass arrow points. Move the compass so that the base of the arrow is at the dot you have just made. Now make a new mark where the tip of the arrow is pointing this time. Keep doing this until you reach the other end of the magnet. Connect the dots, go back and begin again, starting at a different spot than you did the first time. Repeat the above steps. So this is how you will be able to draw magnetic lines around a permanent magnet. It's a 3-mark question, frequently asked in papers, and you have to write details. So I will say that please write it yourself so you master this experiment, writing this experiment. Okay, figure 6.1. Sorry, question number B is done. It's a 3-mark. It was 3-mark question. Question number 6 is part C is on your screen. An unmagnetized iron bar PQ is placed near to the magnet on the laboratory bench. Figure 6.2 shows the 2 poles of the magnet and PQ. So here we have a permanent magnet, North Pole, South Pole, and this is an iron bar, which is not a magnet, but it is a magnetic material. And its left end is known as P, and its right end is named as Q. So what I am doing, the iron bar is initially at rest and the magnet is moved to the right very slowly. When the magnet is a short distance from the iron bar moves very quickly to the left towards it. Explain why the iron bar is attracted to the magnet. Let me explain to you. You see, when you will bring this bar magnet close to the iron bar, which is a magnetic material, due to magnetic induction, this bar magnet will be magnetized. So on the P end, a north pole will be induced, and on the Q end, a south pole will be induced. The attraction between the south pole and the north on the end P of the iron bar will be larger than the frictional force between the iron bar and this table and the repulsion between the south and the south on the end Q. So that's why the iron bar will be attracted and it will move to the left. I have written this answer also. Let's read that answer. On your screen, I hope you are able to see C part of the question number 6. As magnet approaches iron bar, due to magnetic induction, north pole is induced on end P and south pole is induced on end Q of iron bar. South pole of magnet attracts north pole on the end P, and this force is stronger than friction between the iron bar and the table surface. So that's why the iron bar will start moving to the left. It's a 3-mark question, and I hope that it is clear to you now. Okay, so we are moving to the question number 7. On your screen, you can see a student sets up the circuit shown in figure 7.1. You can see we have a battery which is 6 volt, and then we have connected an ammeter. Here we have a resistance of 2.8 ohm. Then we have 2 parallel resistors to each other. One is 3.6 ohm. Here I have a variable resistor. Variable resistance is also called a rheostat. Its resistance we can change, and then the circuit comes back to the battery. Okay. The question is the electromotive force of the battery is 6 volt. The resistance of the variable resistor X is set to 1.8 ohm. Determine the total resistance of the circuit. Okay. So if this is 1.8 ohm and this is 3.6 ohm and this is 2.8 ohm, you want us to find out what is the total resistance of the circuit. So first of all, what I will do, 3.6 ohm, 1.8 ohm, they are connected parallel to each other. I will find their equivalent resistance. They are parallel to each other. So 1 by R equivalent is equal to 1 by 3.6 plus 1 by 1.8. I will get the R equivalent. Once I know their equivalent resistance, their equivalent resistance is connected in series with 2.8. I can calculate the total resistance by adding this and their equivalent resistance. So I will then get, because they will be in series, so simply by adding them, I will be able to find out the resistance of the whole circuit. I have done this on a paper, and let me show you how we did this. Okay. So reduce the size a little bit. Yeah. Yeah. So the two resistors which were parallel to each other, I mean 3.6 ohm and the variable resistor whose value was 1.8 ohm, they were parallel to each other. So their equivalent resistance can be found by 1 by R4 is equal to 1 by R2 plus 1 by R3. So 1 by R4 is equal to 1 by 3.6 plus 1 by 1.8. So when I did the addition on the calculator, the answer was 0.833 ohm. So I cross multiplied it, and the R4 is 1 divided by 0.833, and the answer is 1.2 ohm. Then that 1.2 ohm and that 2.8 ohm, they are parallel, they are in series with each other. Their sum can be found by simply adding them. So 2.8 ohm plus 1.2 ohm, add them, that will be 4 ohm. So you see this part is done. This was a 3-mark numerical in which I have to calculate the resistance, the total resistance of this whole circuit. So the total resistance, once I know the total resistance, which is 4 ohm, let's move to the next part. Then he says the current measured by the ammeter. So this ammeter is measuring the current which is coming out of the battery. The current coming out of the battery can be calculated by a formula. I equals to EMF divided by the total resistance of the circuit. You know, here I know the EMF of the battery, 6 volt, and I also know the total resistance of the circuit. So I can apply, by applying that formula, we are able to find out the current coming from the battery. The ammeter will read that current. I have done that calculation on a paper. Let me show you. The current from the battery, this is the calculation. The current from the battery is equals to EMF divided by the R equivalent. The EMF of the battery is 6 volt. and the R equivalent is 4 ohm, the total resistance of the whole circuit. So 6 divided by 4 will be equal to 1.5 amps. It's a 2 marks. It's a 2 marks question or part. I hope I have made my point clear. The next part, which is question number B, question number 7B part, is first portion is state what is meant by the potential difference across a component in the circuit. Potential difference or potential drop, we also call it, across a component. You see, it is the amount of electric energy converted into any other form of energy when unit charge flows through the component. So it's a standard definition. I have written this definition. Let me show you that. So B first part, potential difference across a component is the amount of electric energy converted into any other form of energy when unit charge flows through that component. This is a definition. I hope you will be able to write it again. Question number B, second part. Add figure 7.1, the symbol for a component that is measuring the potential difference across the 2.8 ohm resistor. Let me take you back to that figure. In this figure, 7.1, if I want to measure the potential drop across 2.8 ohm resistor, I will need to connect a voltmeter parallel to 2.8 ohm resistor. So I will take one connection from here, one connection from here, and here I will connect a voltmeter. A voltmeter should be connected parallel to 2.8 ohm resistor. Then you will be able to measure the potential drop across the 2.8 ohm. I have also drawn this diagram on a separate paper, and on your screen right now you are able to see that. You can see that the whole diagram is the same diagram, but 2.8 ohm resistor, parallel to that I have connected a voltmeter. It's a 2 marks diagram. Sorry, it's a 1 mark diagram. You have to draw a voltmeter parallel to 2.8 ohm resistor. Okay, so we are moving to the next part, which is the third part. The resistance of X is increased. Explain why the potential drop across the 2.8 ohm resistor decreases. Try to understand this. You see, he's saying that I have increased the resistance of X. When you will increase the resistance of X, the equivalent resistance of this parallel combination will increase. The equivalent resistance of this whole circuit will also increase. When the resistance of the whole circuit will increase, the current coming from the battery will decrease. So a lesser amount of current will be coming out of the battery. So when a smaller amount of current will flow through this 2.8 ohm resistor, you see the voltage drop across this 2.0 ohm resistor is equals to the product of the current and the resistance. Its resistance is still 2.8, but the amount of current has decreased. So that's why the product of I and R will decrease, so the voltage drop will decrease across the 2.8 ohm resistor. I have written this answer also. Let me read that answer to you. Okay, that answer is on your screen. Total resistance will increase. Current from battery will decrease. So current flowing through 2.8 ohm will decrease. As we know, V is equals to IR, and R has not changed. So, and I has dropped. So the voltage drop across 2.8 ohm will decrease. It was a 2 marks description. I hope you have understood this. So this was, that is it. After that, we have question number 8 and the section B starts. Okay, everyone. You see, today we have done October, November 2018. 2-1 paper. It's Physics 5054. Today we have just done is Section A. Section A, God willing, we will do in some other video. I hope that I will be to some help to you. I hope that this video will help you in improving your answering skills. Thank you very much, everybody. Have a good day and God bless you all. Thank you very much.